This video is on simplifying radical expressions. So the first one is a square root of 0.36. So this one we're given a perfect square. We need to figure out what number times itself equals 0.36. Well, if you look at 36, you probably know 6 times 6 is 36. But it's 0.36. That means 0.6 times 0.6 is 0.36. And anytime you find something multiplied by itself that equals what's under the square root, you can always pull it out, meaning this is equal to 0.6. All right, the next one is a cube root. So that means figure out what multiplied by itself 3 times is 64. But you notice there's a negative on the outside. That means my answer is automatically negative. All right, if you know your perfect cubes, this one's easy. If you need to work on them, you might want to go through with a calculator. You can always figure out, look at the perfect cubes. This one is 4 because 4 times 4 times 4 is equal to 64. So if it's a cube root, figure out what times itself 3 times is equal to the number underneath. And in this case, it's 4. So our answer is -4. And again, you can always go back, check with a calculator, double check yourself, make sure you did it correctly. All right, so when you're working with square roots, you cannot have a negative underneath the square root sign. That's how you get your imaginary number I. But if you're dealing with a cube root, you actually can have a negative, because a negative times a negative times a negative will give you a negative. Meaning, I first need to figure out what the cube root of 125 is. Again, if you know your perfect cubes, this one's fairly simple. I know that 5 times 5 times 5 is 125. But let's look at the negative part. It has to be, is there anything that we can multiply by itself 3 times to be a negative? Well, if I say, what about -5? A negative times a negative is a positive, and a positive times a negative is a negative. So that means -5 multiplied by itself 3 times is -125. So my value that I can pull out is -5. Always looking at what it is multiplied by itself 3 times that equals what's under that radical. All right. So this one, we have the square root of a negative, and then the 3x is squared. All right, so anytime you have the square root of a negative, that always equals I. So I'm just going to pull out I, that's our imaginary number. Anytime it's a square root of a negative, just pull that out. Well, 3x squared, and we're taking the square root of it. Okay, so you might know that taking the square root and squaring something are opposite operations, so they actually undo each other. So it means that I'm left with a 3x. So we have 3x I. If that part didn't make sense to you, let me break it down a little bit. So we already dealt with that negative. Let's look at the square root of 3x, which is squared. But squaring something just means it's multiplied by itself. So this is just 3x times 3x. Well, we figured out what's multiplied by itself that can be pulled out. The 3x can. So now you can see that squaring and taking the square root are opposites. So it just equals the value that is in the parenthesis in that case. All right, so next one is a 4th root. So what times itself 4 times is equal to what's underneath that square root sign. So, or underneath the radical sign, in this case it's a 4th root. If you need to break it down to its prime factors, you can break it down. So I know that 9 times 9 is 81. and each 9 can be broken down to 3 times 3. That means that 3 times 3 times 3 times 3 is equal to 81. So I can pull a 3 out. 3 multiplied by itself 4 times. Right? X to the 4th. Well, that's just x multiplied by itself 4 times. Okay, so because I found what I can multiply by itself 4 times, I can pull that 1x out. Y to the 12th is slightly different. Okay, so you might be able to visualize what you can multiply by itself 4 times, but here's the little trick. If it's an exponent underneath, you can always take that exponent and divide it by your root out here. So 12 divided by 4 gives me 3. That tells me that y to the 3rd multiplied by itself 4 times would equal my y to the 12th that's underneath. So that means y to the 3rd is what I can pull out. That works as long as it divides in evenly. If it doesn't, you have to figure out something else to go. Something else will stay underneath the square root. But right now we're just dealing with perfect squares, perfect cubes. So we don't have to worry about that yet. As long as you can divide it evenly, you just pull that out. So here's our answer. All right, last one of this type. We have the cube root of x plus 7. That entire thing's raised to the power of 6. So in this case, again, there's an exponent. This entire thing is raised to the power of 6. So I'm going to take that 6 and divide it by the root of 3, which tells me that when I pull this out, I'll have x plus 7 squared as my answer. The way that I know that that works is if I double check myself, x plus 7 squared times itself 3 times is equal to x plus 7 to the power of 6. Because remember, when you multiply bases, you just add the exponents together. Okay, so that's how you know it does work. You can always go back and double check. All right, and then this last part, go ahead and use a calculator to approximate each radical expression to 3 decimal places, meaning go out 3 numbers after the decimal place. So this one's the square root of 4.7. So I'm just going to use a calculator. This one is a TI-30. Square root button is a second function of x squared. So I am going to turn this one on and I'm going to hit second x squared so I get the square root. Type in 4.7, close my parenthesis, and I have to go out 3 numbers. So 2.16, I have to round the 7 up to an 8, so it's 2.168. All right. Next one is a cube root. So my second function of x squared was a square root, but the second function of this little arrow up button, it's called a caret button. That one I can do a cube root, a fourth root, a fifth root. So in this case, I have to type in the cube root. So I'm going to type in 3, and then I'm going to hit second and that caret button. So it's going to be 3 to the power, or the cube root of, and then I'm going to type in 75. Oops, I don't want that. Parenthesis is equal to 4.217 if I go out my 3 spots. .217. Okay. Then last one, I'm going to do the fifth root. So 5, second caret button. So the fifth root of negative, don't hit minus, you have to hit the negative button that's below the 3. Negative 343 is negative 3.214. All right, so those are pretty easy using the calculator as long as you can identify where your the button is where you can do the 3rd root, 4th root, 5th root. All right, so here are some problems, 7 of them. Go ahead and go through, try them out on your own, then I'll go through the answers with you. All right, so the first one is equal to 0.7, because 0.7 times 0.7 is 0.49. The second one, all right, I know that negative 6 times itself 3 times is negative 216. And 9 divided by 3 is 3, so x to the 3rd times itself 3 times is x to the 9th. And I can also pull out a y. I can do 3 divided by 3, which is 1. So y to the 1st, or just y, times itself 3 times is y to the 3rd. All right. On this one, when you're doing a radical of a fraction, I'm going to have to take the 5th root of negative 1 and the 5th root of 32. So you can go ahead and do them separately. So the 5th root of negative 1 is negative 1. And then the 5th root of 32 is 2, because 2 times itself 5 times is 32. So it's negative 1/2. All right, on number 4, you have to kind of be a little tricky about this one. And hopefully you were able to see that this is a perfect square underneath. It's x plus 4 squared, or x plus 4 times x plus 4 would give you x squared plus 8x plus 16. So that means that square root and squaring are opposite, so you're left with x plus 4. All right, then the last part, so square root of 2.7 is 1.643, and we have the cube root. To type in a 3, then the cube root of 32 is 3.175, because the 4 has to round up to a 5 because of the 8. 3.175, and the last one, we have a 4th root of, let's see, I'm going to put parentheses, 0.24 to the power of 2. And so I use that caret button to do to the power of, or you could have just squared it. And that gives me well, this 9's going to round up because of the 8. So if that rounds up, the 89 rounds to 90. So 0.49, I can put 90 or just 49. Hopefully you're able to get those answers.